So good morning everyone. So in the previous class we were discussed the bilinear transformation of the mapping, sir, from one coordinate system to the other coordinate system, or one plane to another plane. That is nothing but if it satisfies, or the transformation can be written in the form of W is equal to AZ plus B divided by CZ plus D. Here AD minus BC is not equal to 0. So that is the condition is there. So here this W plane and the Z plane are said to be invariant points if it can be expressed in the form of like W is equal to Z here. Is it clear? For 3 points, 4 points already we have discussed in the previous class only. So the formula and all. So now in the today's class, so I'm going to prove one important result, that is nothing but the Cauchys theorem. Cauchys. So before that, what is complex integration? Because already in the first semester, first year PU and second year PU, already we have learned that. So integration and its properties, some different types of formulas and all those things already we have learned in the already previous standards. But the thing is here, there whatever the things, whatever the properties and the formulas we have learned, that is only for a real variable. But here strictly we are speaking for the complex variable. So for that reason, for example, if f of z is a continuous function, is it clear? I'll consider f of z is a continuous function with of the complex variable, because instead of f of x I'm just defining z here. Z is nothing but a complex variable. Okay? This f of z is continuous, and for a complex variable that z continuous, z is equal to x plus I by, z is equal to x plus I by, and over the curve capital C, over the curve, so capital C here, then this curve is nothing but, so I am taking circle in general. I'm not going to call this as a circle here. I'm just going to call it as a simple closed curve. So it is closed curve, because directly always I cannot say it is a circle, because that's the only example I cannot give for you for a closed curve here. So closed curve means, so like this also, rectangle, sphere. Is it clear? Rectangle, square, circle, and all those things. So together I'm going to call it as a simple closed curve, that is nothing but C. So that is nothing but, after plotting it graph in the xy plane or the z plane, is it clear? This curve. So I'm going to define the complex integral or the line integral as like this. So line integral, simply I can express like this, or else I can express like this also. This indicates line integral. If I write as it is, so that is also a line integral. But the complex line integral I will call it by using this symbol. F of z dz is equal to, here from here till here it is radius, right? On the circle, on the simple closed curve, and inside the closed circle. Inside the closed circle means from here to till here. Is it clear? Inside the closed circle, inside the simple closed curve, and on the closed curve, on the means circumference of the circle, right? In this case, the value of that line integral is equal to 0. Is it clear? The value of that line integral is 0. That is nothing but a statement of the Cauchys theorem now. So here you should know what is how we are going to define the line integral, and this is the statement of the Cauchys theorem. So Cauchys theorem will be stated as, wait, I'll give you. If f of z is analytic, if f of z is analytic at all points, if f of z is analytic at all points on inside, is it clear? Inside and on A. Here you should understand the statement first. The given function is analytic at all points inside and on a simple closed curve C such that line integral f of z dz is equal to 0 over the curve C. Such that line integral f of z over the curve C is equal to 0. That we need to prove. So from the statement, from the statement, what exactly they have given? Here, first, if f of z is analytic, then what is analytic function here? So first, I am going to define what is f of z here. In the integral, we are having f of z is right. First, let me define what is f of z. So I am going to define f of z as u plus I into v. Is it clear? Z is x plus f and its domain or image f of z is nothing but u plus iv. That is also a complex number. So f of z is equal to u plus iv. Then I am going to substitute over there. But before that, what is z? Z is equal to x plus I by z is equal to x plus I by because f of z is I defined like this, and what is dz now? So dz is nothing but change in the value of z, means increment or decrement like that. So z is dz. Similarly, x plus I by is dx plus I into dy. So let us substitute in this integral now. So line integral f of z dz is equal to, is it clear? Line integral f of z dz is equal to, so line integral f of z is u plus iv into dz. Dz is nothing but here dx plus I dy. So dx plus I dy. Is it clear? So let us separate the real parts and imaginary parts. So what is real part and imaginary part here? How will you separate real part and imaginary parts? Real part is separate parts, right? Real part means I term should not be there here. Is it clear? See, u dx, right? This entire term I should multiply here, right? Like that, I am going to simplify that. So first u dx. So that is equal to line integral u dx. Next, first I'll simplify. Later we'll separate the real parts and imaginary parts. U I dy means plus I into u dy. Is it clear? Next, I'm going to multiply by I for this entire term. I into v into dx plus I v dx. See, plus into plus is plus only, but I into I into I is I square. The value of I square is -1, so it becomes minus v dy. Is it clear? Minus v dy over the curve C here. So now, okay, separate the terms now. Real parts and imaginary parts here. So real parts andre I term should not be there. That's all. See u dx and minus v dy. That term I'll separate first. So line integral C u dx minus v dy. Next, imaginary parts here. Imaginary parts means I u dy, I v dx. There I am going to take I as common factor and I am going to express in terms of another integral here. So plus I is common term. So line integral C u dy plus v dx plus v dx here. See, only two steps I consider here. First, I defined what is f of z and what is dz. After that, I substituted and I separated the real and imaginary parts here. So now, here, don't consider this one. Is it clear? Don't consider the second integral part. Consider only this one. So this is in the form of like this, right? Line integral m dx plus n dy. Do you remember this definition? Can you tell me that? What is the definition of this? Line integral m dx plus n dy. Okay. Very better. Should I write the definition? So do you remember like this? Double integral region dou n by dou x minus dou m by dou y. Do you remember this I'm asking? Into dx dy. Can you tell me? Then what is the definition for this? Don't go for these things, clear. I'm just asking, compare this standard definition with respect to two integrals here. Is it clear? So, line integral mdx plus ndy is equal to double integral or integral over the region R dou l by dou x minus dou m by dou y into dx dy. This is nothing but the statement of Green's theorem. Already I learned in the first semester. Green's theorem. Is it clear? See, coefficient of dx. Coefficient of dx is considered as m, right? Then what is m here? So m is coefficient of dx. Already I said coefficient of dx is considered as m, right? So dx coefficient is there. So that is considered as u. Next, dy coefficient is n here. So n is equal to, right? N is equal to, sorry, minus v here. So now we can substitute over there in the first integral. Later we go for this also. Is it clear? So what about this one? So that is equal to line integral c. First I am going to write only for the first integral. Later we go for second integral. And for 2 times I have to apply this result. Is it clear? See here, m dx plus n dy. M dx is what? U dx. Plus n is minus v. Into dy is equal to double integral. Is it clear? Double integral dou n by dou x. See here, dou by dou x of what is n now? N is nothing but minus v. Is it clear? So n is nothing but minus v. Naming exam please don't neglect. I am telling these things. So definitely you are going to learn in your core subjects in the next semester or in 5th or 6th semester. So for that reason I am just teaching very slowly here. So you should know this because definitely you'll forget this statement Green's theorem and all. But if they ask you at least this term means you should know the Green's theorem statement. This is like that. N in place of n we are having minus v. So for that reason I'll write it as minus v. So minus dou m by dou y. So m is u. So it becomes dou u by dou y into dx dy. This I wrote, this statement I wrote with respect to the first integral. Similarly, another integral is there. So before that, in the statement they have given the given function, that is f of z is analytic, right? Analytic function means already we have solved some applications. You might have forgotten them already. But analytic function means, so it should satisfy CR equation or Cauchy-Riemann equation. Already we have derived and we solved some applications in the previous model. Is it clear? So what is CR equation here? With respect to x and y. CR with respect to x and y. Cartesian form. So dou u by dou x is equal to dou v by dou y, and dou v by dou x is equal to minus dou u by dou y. So at least one term, either dou v by dou x or dou u by dou y, I am going to replace by using this CR equation. Here, dou v by dou x. See, dou v by dou x is what? Minus dou u by dou y, right? In place of dou v by dou x, I am going to replace minus dou u by dou y. This minus and this minus will become plus. So here it becomes like this: dou u by dou y. Is it clear? Only one CR equation I used for replacing dou v by dou x minus dou u by dou y as it is. So dou u by dou y into dx into dy. See, dou u by dou y minus dou u by dou y. Obviously, it will get cancelled, right? So the value of this integral is 0. Means this integral term will become 0. Similarly, we are having another integral. So kindly just respond here for this second integral I am asking that is. So at least what is m and n here? I said already, coefficient of dx is considered as m. Is it clear? Here, coefficient of dx is considered as m. Therefore, M is equal to Vn, and what is n? Coefficient of dy is considered as n. So coefficient of dy is u. So that is considered as n here. Is it clear? So this I am going to substitute here. Therefore, m dx plus n dy. M dx first I should write. So for that reason I will write v dx plus n dy is u dy. U dy is equal to double integral over the region R dou n by dou x. See, n is u, so it becomes dou u by dou x minus dou m by dou y. M is b, so that term will become dou b by dou y into dx dy. Is it clear? So that is equal to double integral over the region R. See, dou u by dou x by using CR equation, dou u by dou x is what? Dou v by dou y. So that term I am going to replace here. In place of dou u by dou x by using CR equation, I will replace dou v by dou y minus dou v by dou y. Dou v by dou y into dx dy is equal to, here dou v by dou y minus dou v by dou y means 1 minus 1 is equal to 0. So the value of this integral is also 0. Here 0 plus I into 0. So hence the proof. So like this you have to prove the result. Only one theorem is there. Okay, so only one result is there actually. Applications are not necessary because anyway you are not going to face the exam, right? But the thing is, these theorems are important. One more important result is there. From that theorem, at least 2 applications I will solve in the next class only. Clear? So this is important theorem not only for your VTU examination. I'm telling, if you are attempting GATE like that competitive exams, definitely these things are necessary. These results I'm telling. They are not asking you to state the Green's theorem and all. Directly, they will give the statement of the Cauchys theorem. If f of z is analytic, then at all points inside and on a simple closed curve on the circumference of the circle, then what is the value of line integral f of z dz? That's all. They will give some options 1, 2, 3, none of this. So obviously you have to go for none of this because on inside and on a simple closed curve, the value of that particular integral is 0. That is nothing but the statement of Cauchys theorem. This you should remember like this. Don't guess and all. Okay. Fine then. Tomorrow I'm going to take one more theorem, and by Friday, definitely Friday only, I'll complete your syllabus. See here, now also I'm just telling for IA. IA will be offline, I guess, from next week, the 3rd, 4th, and 5th. They said according to the college schedule. This theorem I'm going to include, and tomorrow I'm going to prove one result. That theorem also I'll give. See, 5 plus 5 is 10 marks from here. I'm telling for IA. Is it clear? And another model I'll give from complex variables 1. Is it clear? So only one topic is there. Tomorrow I'll complete your syllabus, and Friday 1 or 2 numericals will solve, and we'll finish up this particular semester. Okay then. Tomorrow I'll continue. So if you have any doubts, you can ask me regarding this. Okay, fine. So one application from this, okay, that will be easy for you to how to you'll get an idea how to integrate these type of functions. So evaluate line integral z square into dz. So line integral z square into dz or the curve along the a straight line along the straight line z is equal to 0. Z is equal to 0. Next d along the curve. Is it clear? Along the curve made up of two line segments. Made up of two line made up of two line segments. One from means there are two line segments, right? So those line segments they are given one from z is equal to 0 and another one is z is equal to 3 and another from z is equal to 3 and z is equal to 1 plus I. Is it clear? Z is equal to 3 and z is equal to 3 plus I here. So 3 plus I. Whatever they have given the line segments. So according to that, first let us plot a graph here. But before that, I'll write the definition here. Line integral z square dz over the curve C is equal to. Is it clear? So that is equal to. So we take from 0 to 3 plus I z square dz here. Z square 3z. So now, let us plot these points xy plane or z plane. So till 3 they are given right from 0 to 3 here. So I'm going to consider like this: 0, 1, 2, 3, 1. So y axis let us take. And the height given, see along the straight line, z is equal to 0 and z is equal to 3 plus I they are given. So the equation of these lines joining the points 3, 1 here. So what is the equation of the line joining the points? Yeah, y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. Is it clear? So the points, what are those points? The equation of the line joining the points here: 0, 0 and 0, 0 and 3, 1. Means it is defined at the origin. That is nothing but 0 and 0 at this point, and here it is 3, 1. So let us substitute here. So let us substitute now those points here. This implies y minus y1. So these points are mentioned as x1, y1, x2, y2 here. So y minus y1 is 0 divided by x minus x1. So x minus x1 is also 0. So is equal to y2 minus y1. So y2 minus y1 is what? y2 1 minus y1 0. So 1 minus 0 divided by x2 minus x1. Line joining the points between these points only. So x2 minus x1. x2 is 3 minus x1 is 0. So let me do everything. Okay. So this implies. Okay, fine. So what is that term? Okay, let it be like this only. And what is the integral they have given? So line integral Z square is Z, right? But what is Z here? Z square is nothing but, I said it is a complex number, right? Z is nothing but x plus I, but Z square is x plus I by whole square. So let us simplify that. I mean, separating real parts and imaginary parts. A plus b whole square formula. What is a plus b whole square? X square plus I square y square means a square plus b square plus 2ab plus I into 2xy. So separate real and imaginary parts here. Therefore, z square is equal to x square. See the value of y square. The value of y square is minus 1. So it becomes x square minus y square plus I into 2x y. Real part and imaginary parts are separated here. So now let us substitute in the given line integral. And before that, if z is equal to x plus y, then what is dz? Therefore dz is equal to dx plus I into dy now. So now it is okay. So let us substitute this. So that implies here. Let us substitute here. Line integral z dz. So line integral z square. Z square is x square minus y square plus I into 2x square. Right, as it is. X square minus y square plus I into 2x square into dz. Dz is dx plus I dy. So dx plus I dy. So now same thing. Real parts and imaginary part you must separate. X square minus y square is the real part. And here you should simplify such things, right? How we will simplify it? X square minus y square into dx. Here, x square minus y square into dx. Again, x square minus y square into I dy. That is imaginary, but later we consider minus y square is the minus y square into dx. So, yes. Next plus I into again integral part. Okay, 2xy dx, 2xy dx plus x square minus y square into dy. Okay, you can separate it, right? Directly you can integrate with respect to x and y here. Okay, do integration. No problem. Yeah, do integration. Okay. Yeah. Okay, no problem. You will do yourself, right? Okay, thank you.